Studies Section 8. T-Text. Introduction. In this study section, you will be introduced to another statistical method in psychology that is used for group comparison. Two types of t-tests will be discussed and calculated in this study section. The two types of t-tests are t-tests for independent samples and t-tests for repeated measures. Objectives. At the end of this study section, you should be able to 1. Test a hypothesis using t-tests for independent samples and repeated measures, and 2. Differentiate the two t-tests and know when to use them. Pretest. Why using t-tests for independent samples? Content. T-test. In the use of t-tests, you examine situations where two separate samples are drawn in order to compare the mean difference between the two samples. In other words, t-tests are used to compare two sample means, but not more than two, because it is a parametric test. The t-test was designed for data analysis only when certain conditions are met, which constitute the assumptions underlying the t-test. Assumptions underlying the t-test. A. The sample data are drawn from a normally distributed population, not skewed distribution. B. The data are either randomly sampled or individually sampled from a larger population. C. The dependent variable must be based on either interval or ratio scales. D. The samples are presumed to come from populations that have equal variances. The two variations of the t-test presented in this study section are t-test for independent samples and t-test for repeated measures. T-test for independent groups / samples. The t-test for independent samples is specially designed to detect significant differences between two groups of subjects in a study. An independent group design is one in which the researcher randomly selects subjects from the population of interest and randomly assigns them into two groups, experimental and control groups. It is basically used to compare the mean difference in two groups, thereby assessing whether the independent variable elicited an anticipated behavioral change in one group, not the other. An example is given below to show the procedure in testing a hypothesis using the t-test for independent groups. Example 8.1. A marriage counselor wants to investigate how regional background of a spouse affect marital success. He randomly assigned the participants into two groups, where Group A constitute married partners from the same region of the country, that is, either north or south, and Group B comprises of those whose married partners are from different regions of the country. Ratings of the success of the marriage, the higher the rating, the better the marriage, are obtained. Calculate this using t-test for independent samples. Table 8.1 shows spouses' marital success ratings. Hypothesis like H0 such that x bar 1 minus x bar 2 is equal to 0. That is, spouse region does not affect marital success. H1 such that x bar 1 minus x bar 2 is not equal to 0. That is, spouse region affects marital success. The formula for t-test for independent sample is given below, where x bar is equal to mean rating of marital success for the first group. Y bar is equal to mean of rating of marital success for the second group. Summation S squared is equal to sum of the square of the first group. Summation y squared, sum of the square of the second group. Summation x into bracket squared, the square of the sum of the scores in the first group. Summation y in bracket square is equal to the square of the sum of the scores in the second group. N1 is equal to number of scores in the first group. N2 is equal to number of scores in the second group. Degree of freedom there is equal to N1 plus N2 minus 2. Summation x is equal to 86. Summation x squared is equal to 748. X bar is equal to 8.6. Summation y squared is equal to 472. Y bar is equal to 6.8. N is equal to 10. The calculation is shown below. T is equal to 1.8 over 0.45. T is equal to 4.0. Degree of freedom is equal to N1 plus N2 minus 2 is equal to 10 plus 10 minus 2 is equal to 18. Note, the plus value may be negative, but it is not important, rather, absolute value of the T value. Interpretation. From the calculation, our T value or calculated value is 4.0. This will be compared with the critical value table value in the statistics table using a DF of 18 at one tail test of 0.5 level of significance. The critical value is 1.734 since our calculated value 4.00 is greater than the critical value 1.73 in bracket. We will accept H1 and reject H0. This suggests that there is a significant difference between the two groups. T into bracket 18 is equal to 4.0 minus B less than 0.05. So the interpretation is that spouses from same region, X bar is equal to 8.6, are more successful in marriage than those from different region, Y bar is equal to 6.8. T-test for repeated samples. In T-test for repeated measures, as the name applies, scores are being observed on same subject repeatedly. In other words, two measures obtained must have come from the same participant, and that is why the number of subjects in the two groups must be the same, equal. This type of statistical method is appropriate for pre-test, post-test design, and it can be used to control for extraneous variables. The formula for T-test for repeated measures is given below, where X bar is the mean of the first group, Y bar is the mean of the second group. D is the difference between pair of X and Y scores. N is the number of pairs of scores. Example 8.2. A researcher intends to investigate the influence of an anti-smoking campaign on attitudes of students toward cigarettes. He randomly selects 20 students and randomly assigns them to experimental and control groups. An attitude scale is administered to both groups and their attitudes toward cigarette is measured. The researcher then introduces an anti-smoking campaign to the students in the experimental group for a month of series of speaker class discussion on the health implications of smoking. After this, their attitudes towards smoking were measured again. However, the control group was not exposed to any anti-smoking campaign. The following are the scores obtained in the two conditions. T is equal to 0.71. DF is equal to n minus 1 is equal to 10 minus 1 is equal to 9. Interpretation. From the calculation, our T value calculated value is 0.71. This will be compared with the table value using DF is equal to 9. At one tail test of 0.5 level of significance, the critical value is 1.83. Since our calculated value 0.71, is less than the critical value 1.83, we accept H0 and reject Hi. This suggests that there is no significant difference in the two conditions. T in 9 is equal to 0.71. P is greater than 0.5. The interpretation of this is that the anti-smoking campaign did not have significant effect on the students' attitudes towards smoking. In this case, the researcher needs to examine his intervention strategy to identify what could have gone wrong. Summary: in the study section, two types of t-tests were discussed and calculated. The two t-tests were t-test independent samples and t-test repeated measures. This is the end of study section 8. Thanks for listening.